Are you with me, Shabab? Can you hear me?
Yes.
So as I said,
Yes.
Shabab, this section is about the hyperbolic functions, what they are. After finishing this section, inshallah, you will be able to know what are the hyperbolic functions, why we call them hyperbolic, and what are the hyperbolic identities, and what are the derivatives of these functions. So you know, ya shabab, the exponential function, the natural exponential function. The natural exponential function, it is e to the power x. So when you have a combination, a linear combination of these functions, so when you have e to the power x minus e to the power negative x all over 2, this function, it behaves in a specific way that is important. So it is also this function e to the power x plus e to the power negative x over 2. They notice that these two functions, they have specific features, specific properties, and they are also appears in many applications. So they give them names, and they give them specific names, and they choose carefully the names. They call them hyperbolic sine, this one. They call it hyperbolic sine. Shortly, they write it like sine, and they add h. This h stands for hyperbolic. So, and this will be sine hyperbolic x, and this one, it is cosine hyperbolic x. Why they call it hyperbolic? Why they relate it to sine and cosine? We will see that just in 2 or 3 slides from now. So how to read this, by the way? You can read it as it is mentioned here, hyperbolic sine or sine hyperbolic, because the order here is sine hyperbolic. In some textbook, you will find it written this way. Some textbook, they write it like this, shine. They put the H here, so they write it like this. Or they read it cinch. Cinch. So in some textbook, they call it cinch like this. Also, in some textbook, they just call it SH like this. So whatever, Shabab, we will read it formally as sine hyperbolic, or I used, by the way, I used to read it as cinch or shine. It is up to you. Cinch, sine, cosine and shine. But it's okay, read it as you want. It is just hyperbolic sine. So why they call it a sine, as I said, we will see when we study the identities, because the identities, the relationship between them, it will be similar to the relationship between sine and cosine, the usual trigonometric functions. Now, when we divide this function by this function, so when we have sine hyperbolic over cosine hyperbolic, so it will be this over this, it will be e to the power x minus e to the power negative x over e to the power x plus e to the power negative x. This one, they call it tangent hyperbolic. And the cosecant hyperbolic, it is 1 over sine. The secant, it is 1 over cosine. And cotangent, it is cosine over sine. And so on. So it is similar to the identities that we used in the trigonometric functions. Any question, Shabab? Is this clear? So they are mainly exponential functions, but combined, a sum or a difference of 2 natural exponential functions. The graphs, this is the graph of sine hyperbolic. If you sketch, this is the graph of this function, طبعا. Here it is, the red one here. You can see this is the graph of cosine hyperbolic. This is the graph of e to the power x plus e to the power negative x over 2. Here it is. And this one is the graph of tangent hyperbolic. As you can see from the graph, Shabab, that the domain and the range of this function is all the real numbers. For this one, the domain is all the real numbers, but the range starts from 1. The range is from closed interval 1 up to infinity. For tangent, you can see clearly that the domain also is all the real numbers, but the range is the open interval -1 and 1. Not only that, it has a horizontal asymptotes at 1 and -1. So it is easy. The domain and the range are all the real numbers. Just you need to focus on the cosine hyperbolic, its range is this, and for the tangent hyperbolic, the range is this. Now, why we call them sine and cosine hyperbolic. Look at the first relationship. It has been found that sine, let me mention it here, sine hyperbolic negative x is equals to negative sine hyperbolic, and this is similar to this property. Sine, it has this property. You remember that sine is odd functions. Also cosine, it is odd, even. So this means that this function is even and this one is odd. And this is similar to what we have in the case of trigonometric functions. How to prove this, Shabab? How to prove that this identity, how to prove it? It is so easy. Just use the definition. Do you remember what is sine hyperbolic x? It is e to the power x minus e to the power negative x over 2. So this will be e to the power, instead of x, you will put what? Negative x minus e to the power negative x, it will be plus x. So it will be e to the power x all over 2. Now, if you compare this with this, it is just the same but with a negative. So it will be negative e to the power x minus e to the power negative x over 2. So this will be equals to negative. What is this function? It is sine. It is the same as sine hyperbolic x. So we proved this identity. Now, you can do the same to prove this identity. Similarly, you can prove it. Okay, are you with me, Shabab, now? Also here, this is similar to the identity that we have for sine and cosine. Just give me a minute, Shabab. Let me pause recording. Let's resume. Now, as I said, Shabab, here you can look at this one. It is corresponding to the Pythagorean identity that you remember. You remember that we know we have that cosine squared x plus sine squared x equals to 1. So now it is the same, but here look, there is a little bit difference here that it is minus. Here it was plus, there it is minus. So let's prove this. How to prove it? What do you think? How to prove this identity? How to prove it, Shabab? Any idea?
What's the value of them?
The definition, you mean? Yes.
Yes.
So what is cosine and what is sine? So in this example, we will prove two identities. We will prove this one and this one. So let's start with the first one. To prove it, you need to use the definition, what they are. So what is cosine? Here it is. What is sine? Here it is. Now what you need to do, just do algebra, expand, square. So when you square this one, be careful when you square it. When you square it, will be the square of the first one. Here it is, e to the power 2x. Now when you multiply this by 2, you know it will be 2 times e to the power x times e to the power negative x. And this will be 2 to the power e to the power what? 0. And 2 to the power 0 is 1. 2 times 1 is 2. So this is 2, from where we have this 2. And the square of the last term, here it is. Similarly here, but here with minus. Don't forget that there is a negative in between them. Now, if you calculate now and simplify, collect or combine the like terms, e to the power 2x minus e to the power 2x, it will be cancelled. 2 minus 2, it will be 4. And e to the power negative 2x minus, it will be cancelled. And it will be over 4, it will be 1. So we have proved that cosine squared minus sine squared, it is equals to 1. Cosine hyperbolic squared minus sine hyperbolic squared equals to 1. And if you remember, ya Shabab, do you remember what we had? I said we have cosine squared x plus sine squared x equals to 1. This is for the trigonometric functions. Do you remember what we had? What we called them trigonometric functions? They have another name. Do you know what is the another name for trigonometric functions? There is another name for the trigonometric functions. They are called, if someone asks you, what are the circular functions? The circular functions are the trigonometric functions. Why they call it? They call them circular. If you remember the unit circle, if you put a point here, such that it will be cosine t and t, sine t. What will be the equation? It will satisfy if this is x, if x is cosine t, y is sine t. What will be x squared plus y squared? It will be 1. And this is equation of what? Of a circle. So these two, this identity, it is satisfy the equation of the circle. So this they call it they call them circular functions. And they call them trigonometric from the triangle, from the right triangle, and they call them circular from the circle, the unit circle. We have this here. Look, if you have x equals to cosine t and y is sine t, what will be x squared minus y squared? It will be 1. Am I right? According to this formula. So what is this? This is the equation of what?
Hyperbola.
Hyperbola. And this is now, I think you know now why we call them hyperbolic functions. We call them hyperbolic functions because the main identity that we have here, the main relationship between the cosine and sine, it satisfies the equation of the hyperbola, of a hyperbola centered at the origin. Excellent, ya shabab. So now you know why we call them hyperbolic, why we call them sine and cosine. Now, let's see how to prove this identity. How to prove this identity. You will do the same if you remember as we proved. You need to compare between it and between, ya shabab, 1 plus tan squared x, if you remember, equals to secant squared x. This is for the trigonometric identities. Now, when you have here hyperbolic functions, it is not the same. Be careful. It is 1 minus tan hyperbolic squared x equals to secant squared x. How to prove it, Shabab? By the same idea you did for trigonometric functions. How to prove it? You need to start with what? With the model identity. You can use the definition, by the way. You can use the definition, but it will be longer, ya Shabab. You can use the definition. You are right. But if you use this, we have this, ya Shabab. We have this already. We have it. So the best thing to do here is what? How to have tan hyperbolic.
Divide by cosine.
Divide both sides by what?
Cosine.
By cosine squared x. Look, this will be 1. This will be 1. And this will be what? Tan.
Tanh.
And this will be secant. That's it. You can do the same if you want to prove it for what? If you want to prove
Cotan.
For cotan, what you will do? You will divide by what? By
sine.
By sine. So you will have cotangents hyperbolic squared minus 1 equals to 1 over sine, which is cosecant squared x. So be careful, the identity are not the same. Here it is 1 minus tanh, here it is cotang minus 1 squared, of course. So the identities are not the same, ya shabab. Be careful about them. This is another reason why they related to sine and cosine. You remember, ya shabab, what is the derivative of sine? X. It is cosine x. This is for the trigonometric functions. It is also found that the derivative of sine hyperbolic, it is also cosine hyperbolic. Why? Look, the derivative of sine hyperbolic, it is the derivative of this function. How to differentiate this function? 1 over 2 is a constant, so it is the same. When you differentiate a half of e to the power x minus e to the power x, the half will be out. It is a constant. So now it is about the derivative of this function. And the derivative of this one is itself, it will be a half times e to the power x, its derivative is the same, minus e to the power negative x, its derivative is the same, but this negative, the derivative of negative x is negative 1, so this will be plus. And here we are. And what is this? This is cosine hyperbolic. Cosine hyperbolic. So in general, we have the following derivatives, which are also similar, very similar to the derivatives of the trigonometric functions. The only difference here is the signs. Look, the derivative of sine is cosine. The derivative of cosine is also sine. There is no minus here, not like the trigonometric. The derivative of tanh, it is secant. Look at the remaining derivatives. They are the same as the trigonometric, but all of them are negative now. So all of these are positive and these are negative. The derivative of cosecant, it is cosecant, cotangent, secant, tangent, cotangent, secant, but all of them with negative sign. So it is not difficult to be memorized. Again, now, ya shabab, you need to update your table of derivatives. You need to write here, for example, what is, if x is cosine x, what will be the derivative? It is sine x, sine hyperbolic x. But of course, I advise you to do it with the chair rule. How to do that? And this will be easy. They will not ask you what is the derivative of this, because this is very clear. They will ask you, for example, like this question: what is the derivative of cosine square root of x? So in this case, ya shabab, you need, I advise you, ya shabab, please, all of you, write the table in the table, not only for these functions, for all the functions that you have. Write and ask yourself, what is the derivative of cosine g of x? When you have a function inside cosine, what will be the derivative? The derivative will be sine hyperbolic, the same function, but here you will multiply by the derivative. So this is what I advise you, shabab, rewrite this table with the chair rule like that. Some of you, they may prefer to write it this way: cosine u, it will be sine u, but du dx, the same idea. Du dx, it is g prime. So here, what we will do to differentiate this, shabab? To differentiate this, I know that the derivative of cosine, it is sine, whatever it is inside, keep it as it is, multiplied by the derivative of the square root of 1 square root of x. What is its derivative? It is 1 over 2 square root of x. That's it. And you can write it at the end as sine square root of x over 2 square root of x. Clear?
Yes.
We are done. We are done, ya shabab. This is section 3.11. So these are the two examples that you need to recall them. Let's check our objectives. Did we achieve them or not? Do you know now? Do you know what is the hyperbolic functions? Checked. Do you know the hyperbolic identities? Checked. Do you know the derivatives of them? I think you know now all of these three objectives, ya shabab. Am I right?
Yes.
Let's make sure
Yes, you
about
are.
let's practice. Let's practice to make sure that we got the idea. Who can tell me what is sine hyperbolic 0? What is sine 0?
0.
1.
1 or 0? It will be e to the power. You know
One.
what is sine hyperbolic x. It is e to the power x minus e to the power negative x over 2. So this will be e to the power 0 minus e to the power negative 0 over 2.
So
So
0.
this will be what? E to the power 0 is 1 minus e to the power negative 0 is also 1 over 2. So it is what?
0.
It is 0.
Yeah.
What about cosine 0?
1.
Remember that cosine x
1.
it is the same but with the plus. So it will be e to the power 0 plus. So it will be 1. It will be 2 over 2. It will be 1. طيب, what is cosine ln 5 يا شباب؟ يلا, take a paper and pen and calculate it. Cosine ln 5. What is cosine hyperbolic ln 5?
0.
0. Excellent. Who else أرجع يا شباب? Who has another answer? If you are okay with 0 يا شباب, say 0, no problem.
0.
0.
That's 0.
0.
5.
5.
0.
0. مين يزود؟
26 over 10
26
over 10.
over 10. What is this? Who said
13
26
over 5.
Who said 26 over 10?
نواف.
13 over 5. يرحم والديك يا نواف. الله يرضى عليك. أحسنت. This is the right answer يا شباب. Not this. I know what is the mistake that you did. Thank you, Nawaf. You deserve a bonus.
Welcome.
So now cosine hyperbolic ln 5, it is what يا شباب? It is e to the power ln 5 minus e to the power negative ln 5 over 2. You know, ya shabab, that e to the power ln x when x is positive, it is just what? X, the inverse function of property. So this will be equals to what? 5, because e will be cancelled with ln, minus, what is the mistake that you did? You cancelled also here e with ln, and you write here minus 5. This is, by the way, it is cosine, it is plus. And this is over 2, you did 0 over 2, you said 0. These are the people that they said 0. They cancelled e with ln here in a wrong way. Is this equals to x? No. Is it
1
equal
over
to
x.
negative x? Is this equals to x? The answer is no. Is it equals to negative x? The answer is no. What is it?
1 over x.
It is e to the power ln x to the power negative 1, which is e to the power ln 1 over x. So now you can cancel e with ln, and you will have 1 over x. So here, ya shabab, what we have? We have e to the power ln 5 to the power negative 1. You remember when you have n ln x, this will be ln x to the power n, the power property. Now what we have here, so this will be what? 5 minus 1 over 5, which e will cancel with ln now.
It's a plus, not minus.
Plus, thank you. It is a plus because we are talking about cosine, not sine. Now, where we are done. It will be equals to what? 25 plus 1, 26. 26 over 5 10 times 2, it will be 10. Simplify, it will be 13 over 5. So this equals to 13 over 5. Thank you, Anwar. What about this, ya shabab? What it will be equals to? Cosine 5. Cosine 5, cosine hyperbolic 5 equals to e to the power 5 plus e to the power negative 5 over 2. That's it. If you want to approximate it, you can use a calculator. Okay? So this will be equals as it is, according to the definition. Now, let's talk about the identities. I think we have proved these identities. No need to do more. We have proved some of them. We did this, by the way. You can do the tan also. Oh, I have forgot to mention the other identities, the sum identities here. You can notice, ya shabab, that the sign also, the sign of the sum of two angles, or the sum of two, the sum identity, and also the sum for sine and cosine, they are also the same. But here there is no minus like what we have in the case of cosine of the sum. All of them here are plus. Similarly, this is the addition formula for tan hyperbolic. And this is for the double angle, look, also similar to the idea that you have for sine. But here be careful for the cosine hyperbolic, we don't have minus, it is plus. So you can prove these, ya shabab, easily. Also like this one, it is good when you have ln x. So you need to simplify it and to have it like this at the end. This is not tan hyperbolic x, it is tan hyperbolic ln x. Similar to the trick that we have here. Now, let's now talk about the limits. Who can tell me what is this? What is the limit of tan hyperbolic x when x goes to infinity?
Infinity?
What is it?
No. 1.
1. Excellent. How you know that it is 1?
The range.
The range. You remember the graph, mashallah alayk. Yes. Do you remember, Shabab, the graph of tan hyperbolic? Here it is. When x goes to infinity, it approaches 1. And when x goes to negative infinity, it approaches negative 1. But you can prove it algebraically, by the way, not only from the graph. Assume that you don't know what is the graph, or you forgot how it looks like. You can prove it algebraically. How? This will be the limit. What is the next example? Are we going to solve it? Yes, it's okay. So what is the limit here? The limit of x goes to infinity for what? What is tan hyperbolic? It is e to the power x plus it is sine over cosine. Negative x over e to the power x minus, it will be minus over plus. Am I right? This is the sine over cosine hyperbolic. Now, how to find this limit? Now, this is chapter 5 or chapter 6 question. It is not chapter 5, chapter 2 question. So how to find this derivative? How to find this limit? Sorry. You need now when x goes to infinity, if you notice, it will be infinity over infinity by the direct substitution. It will be infinity minus 0, infinity plus 0, infinity over infinity. Now in this case, you need to divide by the highest power here, by e to the power x. So if you divide both sides by e to the power x, the term will make the problem. This is the infinity here. So divide by it, what you will have? You will have 1 minus, when you divide e to the power negative x, when you divide it by e to the power x, what it will be? It will be e to the power negative 2x. So this will be e to the power negative 2x over 1 plus e to the power 2x. Similarly, now you can take the limit. What will be the limit now, Shabab? The limit will be 1 minus, this will be what? 0. And this will be 0. So it is 1 over 1. It is 1. When you solve this question, you will divide by this term, by e to the power negative x. You will do the opposite. It will be e to the power x over e to the power negative x, which will be e to the power 2x. And also the limit here will be negative 1. You can check that, Shabab. I will leave the others for you to practice, Shabab. Now for the derivatives, we have here like 6 derivatives. You can solve any one of them, Shabab. For example, let's solve this one. It's okay. You can also simplify, like here, you can simplify and then differentiate, or you can differentiate from the beginning. It's okay. So now here, what is the derivative of this one, Shabab? Now what will be y prime? It is exponential function. You remember that when you have exponential g of x, its derivative will be what? Will be as it is, but multiplied by the derivative of the power. So here it will be as it is, e to the power cosine 3x, but you need to multiply by the derivative of cosine 3x. Now the question is, what is the derivative of cosine 3x? The derivative of cosine hyperbolic, it is sine hyperbolic. But also we have 3x. So what is the derivative of 3x?
3.
3.
This is the answer. This is the derivative. 3 sine hyperbolic 3x times e to the power cosine 3x. Here you need to apply the product rule, ya Shabab, because here you have a product of two functions. You have also to apply the chair rule because you have cotangent of another function, cotangent hyperbolic. Also, I will leave them for you, Shabab, to practice. And I will give you now like 2 minutes to solve this, please. This is an old exam question. Please take a pen and paper and start practicing by solving this old exam question. If cosine 3x minus sine hyperbolic 3x equals to 3, then what will be sine 3x? And let me launch a polling. Shabab, do you need more time or it is enough?
Just a little bit.
We have like 12 students, 13. You can solve it by 2 methods, ya Shabab, by 3, by different methods, by the way. But I think it's okay. So let me finish the polling, ya Shabab. If you want to vote, vote now. So this is the end. So we have like 29 students. Let me share with you the results. Most of you, they went with A, and some with B, and of course, only a few with C, D, and E. The answer is C. The answer is C. Who got the right answer, ya shabab, by solving? If you solved correctly and obtained C, please share with us your idea.
I
Who
got it.
solved it, ya shabab?
Me.
Nawaf, is there any
Yes.
another one other than Nawaf, ya shabab? Okay, what is your idea, ya Nawaf? How you did that?
I put the definition and then
You
I solved
used-
the equation.
Yes, you use the equation, the definition. It is good idea. So, but there is another idea, but it's okay. Let's did what Nawaf did. Nawaf, he used the definition. So Nawaf said this will be e to the power what? 3x,
3x.
plus e to the power negative 3x over 2 minus e to the power 3x minus e to the power negative 3x over 2 equals to 3. Now, if you combine and simplify this expression, what you will have? This will be cancelled because of the negative here. So you will have this minus minus, it will be plus. It will be 2 to the power negative 3x over 2 equals to 3. Now this will be cancelled, so you will have negative 3x, 2 over 2 is 1, e to the power 3. I advise you to stop here. So this is e to the power negative 3x. You can solve it for x, but no need. What I will do, I will go here now. Sine 3x, what is it? It is e to the power 3x minus e to the power negative 3x over 2. Now, what is this? This is equals to, what is this, ya shabab? This is 3. So it will be minus 3. If e to the power negative 3x is equals to 3, what will be e to the power 3x, ya shabab? It is 1 over 3. E to the power negative 3x. It will be 1 over 3. So this is 1 over 3. All over 2. This will be 1 minus 9, negative 8 over 2 times 3 is 6. So this is negative 4 over 3. Thank you, Yanawaf. Another idea, Shabab, is to use what? To use your algebraic tricks. So what I will do here, if you just do this, sine squared 3x equals to, move it to the other side, it will be equals to cosine 3x minus 3. Am I right if I did that?
Yes.
What I did, I moved
Yes.
sine to here and the 3 to here, to up there. Now I will square both sides. Square both sides. What you will have? You will have sine squared 3x equals to, square this, what it will be? It will be cosine hyperbolic squared 3x minus 6 cosine 3x. Oh, it will not be good, by the way, because I need to find what, ya shabab? I need to find sine hyperbolic. So it is better here to move the sine to the beginning. So I will go back because this is not what I want. I want sine. What I will do, I will square, I keep cosine squared, cosine hyperbolic squared. So what I will do, I will just write it as cosine hyperbolic 3x equals to 3 plus sine 3x. Now square both sides. It will be cosine squared 3x equals to 9 plus 6 sine, and this is what I want. This will be sine 3x plus sine squared 3x. Now, cosine squared 3x, what is it? Do you remember what it was? It is 1 plus. Remember the relationship between it. Cosine squared 3x minus sine squared 3x equals to 1. So now move it to the other side. This equals to 9 plus 6 sine 3x plus sine squared 3x. Now this will be cancelled with this. And what you have, 9, move it to here, it will be negative 9 plus 1, negative 8, equals to 6 sine 3x. This means that sine 3x equals to negative 8 over 6, which is negative 4 over 3. That's it. Any question, Shabab? Okay, you have here, Shabab, here several old exam questions that you can practice, and this is the end now we can say goodbye chapter 3, and let me just in the remaining few minutes introduce you to or introduce chapter 4 for you to you. Chapter 4 يا شباب, we have like 5, 3, 8. We have 8 sections in this chapter, and this chapter is about the applications of differentiation in the mathematical analysis and also in the real life problems. I'd like to give you this introduction at the end of this class and before the next class. What we are going to have in chapter 4 and why we need it. Some of the most important applications of differential calculus, the derivatives, are the optimization problems. What are the optimization problems, ya shabab? They are problems in which we are required to find the best way of doing something, the optimal way. Like, what is the best shape that we can have to minimize the cost of any product? What is the best case that we can have the maximum acceleration for a car or for a space shuttle or whatever? And what is, for example, the radius of the concrete wind pipe that, of course, make it most effective? What, for example, the angle that we should have in the for balancing, of course, the energy and the pumping the blood, for example, in medicine? It is about the maximum and the minimum, the best optimal case that we could have. But we will do that with the help of the derivatives. So we need to start with the maximum and the minimum values, which we are going to study in chapter 4 in 4.1. We will do that, inshallah, next class. So this is all what we have for today, ya shabab. And if you have any question, I can have like 1 minute or 2 before going to the another class. So I will stop recording.